uh, delivering a lecture on this topic. So although although this conference is related to medicines and the biological engineering department in NIT Rourkela, but I'm not going to details about all these biological aspects or other things, because as you know, so my specialization is only in this computer science. So I'll just only talk about these like these computational models that you could apply in your area or in your area of research. In this specifically, this is a modern AI techniques that we call it as a deep learning approach. Okay, and also you can apply these conventional machine learning techniques, so on and so forth. Okay, so that's why that the topic of the this lecture is artificial intelligence applications in healthcare. So now basically, as you can see that there is a applications of AI that can be. I'll just touch upon the very brief introduction of this how where AI can be applied and what are the benefits of AI that people can achieve in this biological engineering and the medicines. So now there is a two types of applications of AI in medicines that can be categorized. One is the virtual branch, another is called the physical branch. And also, there's a lot of innovations are going on in the field of medical and the biological engineering. So with the help of the different AI techniques. Okay, so there are different AI techniques which actually needs the machine learning and the deep learning facilities. Okay, to highlight or to heighten their diagnostic studies, different treatment plans, or understanding different symptoms of the disease, different behavior of the disease, or any kind of these pathological norms, and so on. It continues. So now, as you know, that as you are, all of you are these biological, students or experts in this domain. So in the early days that we used to have, that is a different kind of innovations that we have seen, starting from, if we are starting from this artificial kidney, that how it can be developed, and this some X-rays also that it is an early development that we have seen. Then the electrocardiograms, then these cardiac pacemakers, or then you will have this computer assisted tomography. Then we had, this is a nowadays that people will have this very smoothly artificial limb and the knee transplant. Then these MRI images that people could work in this domain, and we're having this laser surgery, so on and so forth. Now recently that we are applying the concept of the deep learning approach to understand this data analysis portion, because as you know, there's a this deep learning is a very vital techniques which comes under the artificial intelligence, and people are using this is a deep learning approach, okay, to understand these data and to apply any different classifications algorithms. Okay, if you could just have the difference between suppose if you take if you want to take a decision that whether this that is tumor is a malignant or is a non-malignant, so how you are going to take a decisions. Okay, so in this case, that is in the field of this medicine and the biological engineering. So currently, you guys will be working in the field of the genomic sequences and these microarrays. Okay, and some image-guided surgery. So in order to understand or in order to handle this type of problem statement, so you could also apply there's a deep learning techniques, and which is very important and very essential. Okay, in this field. So now today we'll only talk about few portion of these things. So how you can see these things. What are the different types of learnings are involved to handle these biologicals or these medicine type of applications that you can looking forward. So now this in the virtual component, it can be represented by the machine learning, or you can say the deep learning. So it is there is a mathematical model, or it involves a lot of mathematics. So any machine learning algorithm that you'd like to understand. So three important things that you need to know. One One is called, this is a linear algebra, so that is important. There is a probability and statistics. Third one is called the calculus. So now if you understand these three rudimentary concepts of these things, then it will be very easy to understand these ML or DL concepts, because you have to go through the different types of mathematical model, functional approximations kind of things that you need to think of it. Because if I would like to tell you, you just develop your own classifier. Okay, so now how you are going to develop your own classifier, which will be suitable or best suited for your particular data. So now before designing a classifier, you need to first understand your data. So that's why the data analysis is very important part. So analysis of the data comes under the, you first understand the distribution of the data first. Okay, so now distribution of the data is very, very important for choosing a particular classification model. So that things that you should not use blindly ML and DL techniques. You should first understand this data. Okay, understanding this data, then you'll have to understand the features. What important features that you would like to extract that at your end. So that is also important. So that's why in the machine learning, that people are working in the field of this unsupervised learning. Okay, so unsupervised learning, basically that it comes under this, I mean, it is actually called the clustering, because you do not know the class level of the data. So that is called the unsupervised learning. And in the supervised learning, because you know this class level of the data, I mean, the person that you're going to classify, that you know that what will be your class exactly. So you know this training data, so the training data set is given to you. So now that is called the supervised learning. And next, there is a very important concept is called the reinforcement learning. So you could apply in your case, because people are working in this field of reinforcement learning. So now, and if you understand the concept of the reinforcement learning, and if you know the deep learning, they said the concept is called the deep reinforcement learning. There's important concept. So now, what is a reinforcement learning? I just tell you this one things is there. So now it is, so you do not have any training data set at your hand a priori. So now you have to take a decisions. It is bound to learn from its experiences. Suppose you just think of your chessboard. Okay, so in the chessboard, so what you have to do? So you'll have to just do some particular steps. So based on your prior experiences. Okay, so it is called the learning from its experiences. So in a nutshell that you can see. So now you have to take a appropriate action. You have to take an appropriate action or suitable actions in order to maximize the reward. So in the reinforcement learning, there is a concept is called the reward. Okay, so taking appropriate action in order to maximize reward in a particular situations. And in the reinforcement learning, there is a different agent will be there. So I'll talk about one example. In the reinforcement agent will decide so what to do to perform this given task. Now here, as I told you, so you do not have any prior training data set, so it is bound to learn from its experiences. And in the reinforcement learning, so you have a positive reward, you have a negative reward. Okay, and you have an agent, you have a reward with many hurdles in between, and you'll have to, the agent has to choose, or agent is supposed to find the best possible path to reach this particular reward. Suppose you have a 3x3 grids, and in the grids, so you have a one robot. Next is you have a one target, so and you have some hurdles. So now the robot has to move, and robot has to pass, or robot has to cover certain paths in order to reach to this particular reward. So now if the robot has to find a one best possible solution, so if the robot is going to have the best possible solution with minimum reward, with minimum hurdles, then obviously, so this reward has going to be maximized. So this is very interesting algorithm. So you could explore your idea in the field, in this thing. This is called the reinforcement learning, because when you do not have any training data sets, and in the absence of the training data set, so it is actually bound to learn from its experiences. So this is very important things that people are, you could explore this area. This is called the reinforcement learning. Okay, and there is what are the main benefits of the artificial intelligence? Why we are here to learn this AI? So there is a plenty of applications that you can find that AI can definitely assist different physicians. There's a clinical decision making. For the better clinical decision. Okay, and also it will also replace human judgment in certain functional area in healthcare. In the automations that it will take and things smart decision making ability. Okay, now the prediction of outcome, whether this, suppose there's an example is there, this is a cancer classifications, whether the cancer is a malignant or is a benign. Okay, you'll have to going to take some data sets. You have these two class classifications problem, binary class. Now you have some certain images with some pixel intensity values. You have to extract some intrinsic information from those images. So from that intrinsic information, taking into consideration those intrinsic information, you'll have to train your model. Then you have to classify it. So now that is the things that is it is very much useful. AI techniques for the early diagnosis of the different diseases. That is very much thing. There is, suppose all of you know, in this field of this Parkinson disease is one of the important disease. It comes combined with the musculoskeletal disease, or you have the autistic children that you have seen. So there is a neurological disease. Then the cerebral palsy, multiple sclerosis. So all the disease. So now if you would like to make a one prediction model for early diagnosis of those kind of diseases, so it will be wonderful research in this field of this biological domain. And if you could apply some different modern AI techniques, so how the AI techniques can handle this type of things. So people are working in this field. They are working applying this artificial neural network, radial basis function neural network. Okay, then probabilistic neural network domain. Then they are nowadays people are working this deep learning approach, starting from the convolutional neural network and applying this. Then RNN neural network. So and there's a generative adversarial network GAN. So those are these nowadays. There's a very important tools, but you need to fix up your applications. Which application you like apply blindly, or the first thing you need to understand the techniques that you are going to apply. Is it really suitable for your case? So that's a lot of rigorous, analysis or this investigation is important. Okay, like this feature investigations, whether the features is really important, because suppose you are going to extract some features from these images. So now before applying to the classifier, you need to first understand that whether the features is really important or not. So how do you judge it? Then you will have to apply some statistical techniques, starting from like this. You can apply some ANOVA test, analysis of variance for the feature reliability testing. Then you can apply t-test, student test, t-test. It is just a hypothesis testings. Okay, then you can apply the f-test, Fisher test. So those are the things that you can apply, so before taking a decision. So now here you have some inputs for a particular problems. In the inputs you have different symptoms. Okay, and as I already told you, you have this set of features will be there. Then you have to train a particular model. Okay, so whenever you are trying to apply to a classification model, so it will have some mathematical format, and you need to first understand that what type of input this model would expect, would accept. Then you'll have to do it. You'll have to just take into consideration those input in this way. Then you have to just see that how the processings can be done. Okay, suppose if you would like to apply this multi-layer perceptron. Okay, if you apply the NN model, so now NN it is a multi-layer perceptron, so more than one hidden layer is there, and then you can apply the backpropagation algorithm. So you have this set of inputs. Then you have a hidden layer. In the hidden layer you have a set of nodes. Then you have this output layer. Then you could get this output. So output will be either positive. If it is a two-class classifications problem, then you will have the positive, negative. It is a multi-class, then you have a sequence of classes will be there. So in this way that you will have to think of it, and how we are going to apply it. So these are the specific benefits that people are looking for to this thing. So next is called the physical branch. So in the physical branch also, so it is also very important things that people can using AI techniques in medicine. Like this in the physical objects. Now different medical devices, like as you can see, there's a ZigBee local area, or you can see the body-worn network or body-worn sensor network. Suppose you would like to put on one EMG signal, I mean EMG sensors, okay, in your body or in the muscles or in the leg, and you would like to find out its muscles activations pattern, and through the muscle activations pattern you could predict some actions of the persons, okay, whether the person's behavior is a normal or it is abnormal. So now that kind of things that you could have. I mean, there's a obtrusive techniques. Okay, so there's an obtrusive procedure. So there's a direct connectivity of the sensor to the body. So this is body on sensor, or you could have accelerometer kind of sensor. It is called the IMU sensor, inertial measurement unit sensor, IMU. So in the IMU, you will have these 9 degrees of freedom, or I mean 3 degrees of freedom for accelerometer. So it will give it to the linear acceleration, and another 3 degrees of freedom it will have the gyroscope. It will give it to the angular velocity. So in this also you can have. So in the set of things that you could apply in your body, and you could directly or indirectly you can transfer your data to your computer. Then you can you can do. You can start the analysis. So these are the process that people are working in this field. Like there's a cardiac continuous measurement for the stress detection. How you are going to measure the stress, okay, of the particular person. So now whether the person is, whether the stress is going to affect for the cardiac arrest or not, means kind of things that you can evaluate it. So using some body or sensor. So now these are the very important things that you need to explore where the AI techniques is coming, because whenever you are going to deploy these sensors, then you have to do, if some fusions is required, then you have to do the sensor fusion, then you have to do some pre-processing techniques, some filtering, then noise reductions, okay, outlier detections, then you have to extract some important features, then apply some classification model. Okay, so this is the process that you can do in this way. So now this use of robots also, that is means deliver this treatment in this field, that is called the robotic surgery. So you can also see there's a if you have going to have some automations, or if you could see that how the AI techniques can be useful here. You just put this the way that human being thinks. I mean the way that a human, you are just transferring the human intelligence to the machines, so that the way the person thinks or human thinks, so robot will also think in this way, and robot will have the decision making ability to do this particular operations in this way. Okay, so this is called the robotic surgery. So it is, I know it is a very extremely difficult. So you need to have that type of facilities, and the robot must be very accurate. So there's a two important things in robotics that is important, that is called the precision and repeatability. So now the precision and the repeatability that you need to be taken care of, okay, to do certain this type of job. Okay, so if any wrong things is happened during the operation, then obviously there is a there is a chances of death of a person. So you have to be very cautious about it, and you have to plan it accordingly. So now this is one type of applications that in the AI application there is a robotic surgery, and also this use of robots that use to monitor the effectiveness of the treatment that you can have. So it is actually a high-end thing. So no need to think of it in this way. It is just an application. So now if you just try to understand this why AI techniques is important and how you can apply the AI techniques. So that is the thing. So this is the basic two questions that you need to understand. So that is why the intelligent machines, or what machines can do, that you need to know. Okay, so now there is a two important questions that that is things is how does a human mind work, and can a non-humans have minds? So these are the two questions are still unanswered. Okay, so now in a nutshell, in a common language, how the intelligence can be. So intelligence can be defined that it is the ability to think or to understand, okay, or to learn or understand in order to solve a particular problems and to make a decision. Now the questions comes, okay, what is exactly artificial intelligence? So now AI actually, if you have see different books, so different books there will have the different definitions. Okay, but the questions come that if you could like to transfer this intelligence, human intelligence, to the machines, okay, and you can try to make a machine in such a way so that the way that human thinks, then the machines can do the same job. Okay, and it will have the decision making ability. So human, our so we are the this means creature. Okay, that is, we are having this intelligent power. Okay, so and we have the decision making ability. And now if you would like to transfer in this very small unit of things, if you would like to transfer to a machines, so and if you can make that machines can do the same things, then also obviously the problems will be solved. Now, how the questions come that can machines think? Okay, the answer cannot be only a single answer, yes or no. So now, can machines think? To answer these questions, so one of the most uh, mathematicians, or you can say the computer scientist, his name is Alan Turing. So I think all of you have heard his name. So in his paper, there's a computing machinery and intelligence. So there's a British mathematician, Alan Turing. So he developed one test that is called the Turing test to check. So without any semantic information, without any going through any definition. So now he have made a Turing test. So now this Turing test, actually it is a method to inquire it is a method of inquire of AI. Okay, for determining that whether or not a computer is capable of thinking like a human being. So this is called the Turing test. If any machines pass the Turing test, it means that the way this human being thinks, also the machines or the systems can think. So that is a very wonderful test, and there's a very popular test. That's what is called the Turing imitation game. Okay, the game name is Turing imitations game. That is called the Turing test. It is a method of inquiry of AI for determining whether or not a computer or a machine is capable of thinking like a human being or not. Okay, so now the game is originally divided into two phases. Okay, in the first phase, what he does, there are three separate rooms were available, and in each room, so three persons was there. Okay, one was the interrogator, another was the man, another was the woman. Or each were placed in separate rooms. Now, the interrogator objective was that to find out who is the man and who is the woman. Okay, sitting in the different places by questioning them. So each computer was connected some terminal, and the interrogator was asking some questions, and they are liable to give their answer. So based on their answer, the interrogator had to take the decisions: who is the man and who is the female. Now, the main objective always should attempt to deceive the interrogator that he is the woman, while on the other side, the woman has to convince the interrogator that she is the woman. Okay, so this is the things. That is a Turing imitation game. That is a very popular game. That is phase one. So there is an interrogator. So these are three different rooms were available. Now they have to do some communication. Okay, using some text. Okay, and now after some time, that in the second phase of the game, the man was replaced by computer program. Okay, so actually the Alan Turing was very popular, and he has done tremendous contribution in this theoretical computer science. Okay, so that's why in this honor of his name, there is a in the computer science there is a called the Turing Award. Okay, honor to honor him. There's a Turing Award. He's a tremendous contribution in theoretical computer science. Okay, so now next, the man was replaced by a computer program to deceive the interrogator the same way as the man did. Okay, even though so there would have been written some program to make some mistakes and to provide some fuzzy answer also, there is no problem. But if the computer program can fool the interrogator the same way that this man did, it means that the computer has passed the intelligent behavior test. So that is called the Turing test. Okay, and that was a very important to check that can the machine think. Okay, to give these answers. So there's a very good test is called the imitations Turing. So that's why it is the start of the He's called, there's a father of AI that you can say. Okay, there's Alan Turing, and this yeah. So actually, this use of computers. You can use a computer. Now, what is an AI? So now you can use a computer, okay, to model uh, intelligent behavior. So you'll have to model the intelligent behavior with minimal human interventions. You can use, so yeah, means you have to use a computer to model this intelligent behavior with minimal human interventions. Okay, and these computer programs are actually capable of problem solving and learning. There is two important. One is called the problem solving and the learning like a human brain. Okay, so these are the very important things. So now you have to first understand the basic AI. Okay, then the AI techniques that will come up. So basic AI, these are the things. Okay, it is starting from the Turing imitation game. So next, uh, it is called now, as you can see that there's a computers. I mean, this interrogator convinced that the computer, it is actually a man. Okay, so these are the tests. So next is called there's another revolutions that it was done in the AI. It's called the expert system, developing and expert systems. So all of you has think there's a term is called the expert system. So there's a different type of expert systems are available. There is one is called the rule-based expert system. Okay, at that time in the early days. So in the early days that people were using. So when at that time there is a no computers programs was very smart at that time, and very common programming AI-based programming language was there. So whenever there is a called the AI programming language, it comes under the Prolog, PROLOG, Prolog. Okay, programming in logic. That's called the Prolog. So Prolog is in the early days, people used to write their rules in the form of the Prolog programming language. They Lisp, LISP, Lisp programming language. Okay, then CLIPS, CLIPS, Clips. So Clips, Lisp, Prolog. These are the programming languages that people are using at that time when there is no kind of computational facility were available at that time. So they have to write a set of rules, 1,000 rules. Okay, then these 10,000 rules, and based on that, then applications. But the major things is called the expert system. So in the expert system, there is an important concept is called the knowledge base. As we can say, in the knowledge base, it stores a lot of relevant informations. Then it can hold the data, different rules. Okay, and there's an important concept is called the inference engine. So there's a bi-directional connectivity between inference engine and the knowledge base. Because in the inference engine, you'll have to write a set of rules, and these rules in the rules will have two parts. One is called the antecedent part, another is called this is a consequences part. Okay, now in the antecedent part means a if then rule. Okay, if these first things is true, then this next things will be either true or false based on this criteria. Okay, now so first this is a first part is called the fact. So this fact value has to be matched with the knowledge base data. If it is matching, then only this rule will be fair. If it is not matching, then you will have to look for the other rules. So these are the things that you can go with this thing. So now a rule means a conditional statement. So as I already told you, it is a conditional statement. As you can see in the C programming language, you are using a conditional operator. Okay. So now here also you will have to have conditional statement that links a given conditions. Now the given condition will be there in the rules. Then to have appropriate actions or outcome. So if I write that is a Socrates, all men are mortal. All men are mortal. Socrates is a man. Then Socrates is mortal. So Socrates is mortal is a there is a conclusion. So in this way that you can infer. So you'll have to infer from two consecutive rules to one rule. Okay, X implies Y, Y implies Z. Then you can infer X implies Z. Okay, so X implies Y, it is a one rule. Then Y implies Z, it is another rule. Then by using these things, you are going to have X implies Z. Okay, so in this way that you can think of it. And whenever you have these experts, the expert's opinion is very important, means domain knowledge. Whenever I'm telling the expert means for one particular problem, these persons you need to take the advice for this problems, or you have to take the advice of these problems. Suppose in the early days, people are using two important expert systems. One is called the Dendral. Okay, so it is also AI based expert system. So at that time, there was no scientific algorithm available. So now the Dendral expert system. So it was developed, I think, in 1970s. Okay, by the Stanford University. It was this first expert system that is developed in Stanford University to determine the molecular structure of the Martian soil. It is based on this mass, spectral data, which was provided by this mass spectrometer. Okay, and this project was supported by NASA. And there's a scientist was there. Okay, Liederberg, he was the Nobel Prize winner. So he was this main advisor or the domain expert. Okay, taking his expertise knowledge, the rules was formed, then applied, and the rules were written in the form of the Lisp programming language, then to solve this particular problem. Okay, now there is no scientific algorithm for mapping this mass space spectrum into its molecular structures. So now this person's job was to incorporate all the expertise knowledge into a computer program and to make it perform. This is a very good expert system that people are using at that time in 1970 algorithm. Then after that, the Mycin was very popular. I think all of you have heard this name is Mycin. Okay, so Mycin is an early expert system. So it used then there's a backward chaining algorithm. I think it was also developed in 1970s or 72 perhaps by the Stanford University, and it would attempt its objective is to attempt to diagnose patients based on the symptoms and the medical test results. So now, this expert system was for diagnosis of the infectious blood diseases, and it also provided this expert system also provided the doctor with therapeutic advices. Okay, in a convenient and user friendly manner. So now, whatever that rules that was formed in the Mycin expert system, there's a total 450 rules were derived or it was written from the human knowledge. Okay, because whenever there is a no doctor is available in a particular center, then if you just give the persons or the patient's symptoms or the medical test, then it will just attempt to diagnose this patient, that whether this patient is going to have this infectious blood disease or not. Now people are using image processing tasks to very quickly to solve this. There is no right to read, no right to no need to write these set of rules. Okay, so only that if you have the smart machine learning techniques, okay, just you can quickly get the answers. So these are the because at that time there is no scientific knowledge, so people are using. Okay, so now next I'll just discuss very few my research contribution that I'm working on in this field. One is called understanding the human cognitions. Okay, through this motion analysis, and this, as you can see, that AI techniques can be applied to solve any type of complex problems in biomedical engineering domain. Okay, or you can say in the AI subfields, it includes these neural networks, starting from neural networks, computer visions, computational model like these genetic algorithms, fuzzy logic, and artificial neural net. Then you have some nature inspired algorithm. Then you can start with some robotics applications in biomedical engineering domain. That also if you could do. Okay, so now what I'm doing or my research team is doing. So we are using the very low cost device that is called the Microsoft Kinect as a vision sensor to capture this person walking pattern, and we are using an emotive neuro headset, EEG headset, that we are using to capture the person's different cognitive states. there's a which states, I mean, whenever a person is having happy, sorrow, or any kind of thing, so we are going to capture this type of different mental states, and I'm trying to predict this person cognitive states through his walking pattern by using some different machine intelligence techniques. And another thing that we are working, there's a wearable sensor based, as I already told, explained you. If you put different wearable sensor like the IMU sensors, EMG sensors, or you can put the accelerometer, okay, so on and so forth. So now we are using the IMU sensors based clinical gait analysis. So we are focusing on the population of the cerebral palsy, CP, and autistic children, or that we are working in this field. We are trying to do some recovery predictions, so recovery prediction of those diseases. Okay, so this one of that in this field. So one is called the inertial measurement unit, and we have developed a one tool that is, it is already copyrighted. So modeling pathological gait with convolution neural network. So it is a visualization based gait assistive tool. So now actually those who are not aware about this clinical gait analysis, so this is very wonderful field that you could explore. That is, what is a gait? So gait means it is a person manner of walking. So everybody will have different style to walk, and this walking pattern is varying person different parameters. Like this, there is a anatomical parameters. Okay, person height, weight, age, whether the person is male or female, and so on. And there is a different types of gait that you could see, and this gait analysis is very useful to detect certain type of gait abnormalities. So my research is, I am applying different AI techniques to develop some healthcare systems. Okay, so that these systems, AI-based system, could be useful in the common people to diagnose different type of diseases like the hemiplegic gait, or this equinus gait, drop foot gait. So this type of gait. Okay, so it will solve this early diagnosis of this some Parkinson disease, or like the cerebral palsy, or the autistic autisms. Okay, or you can say the autism spectrum disorder, ASD, autism spectrum disorder. This is a very wonderful area of research that you could explore in this field. So one of my PhD students is working in this field as ASD, and he's working, applying some different advanced reasoning techniques. Okay, to do some recovery prediction. So now application of this gait analysis, that you will have it sports biomechanics. So now if you see that this athletics, that to find these injuries, that if we also detect this how much injuries are there on the person's muscles, using this comes under the sports biomechanics. There's a biometric identifications, then rehabilitation, then the clinical that we are working in this field, robotics. Then there's a different gait analysis techniques. One is called this qualitative gait analysis. Qualitative gait analysis is a manual kind of technique. So there's a GMMS score is there, and persons. So it was not robust in this domain. So manual processing, you could say. So we are working in the field of this quantitative gait analysis. So quantitative gait analysis means that we are using the different image data, video data, and some EMG sensors data, IMU sensor data, and also next there is a different type of motion sensors that you could see. Wearable sensor like this IMU sensor, okay, goniometer, ultrasonic sensor, EMG sensor, that one picture was shown to you. So you can put, there's a body on sensors. Okay, so IMU sensor you can put EMG sensor and the ultrasonic sensor. Next is in a non-wearable sensor, you have the vision-based sensor like the depth sensor, because the Kinect sensor that we are using, so it has got the depth sensor, and you can easily get the background subtracted images. I mean depth images that you could get, or you can use this 2D camera. And the other, you have the pressure mat and the force plate also that you can use to. It also comes under this non-wearable sensor. So different gait parameters. You have this spatiotemporal, this kinematic. There's a kinetic and the anthropomorphic. So these are the different. It is a common thing, so no need to explain. So these are the different motion capture cameras are there. One is called the Vicon camera, so it is very costly camera. Another one is a Qualisys camera. I think in biomedical department, this Qualisys camera is there probably. So because I went there with my team to capture this gate data, and in OptoTrack systems also it is also very famous, and we are using this is a low cost kinet sensors. Okay, so that it can be affordable. So using an affordable system, how could you make gate analysis, gate assessment system using different machine learning techniques? So that is our objective. Okay, and these are the different types of gates. That is a normal gate, cerebral palsy, multiple sclerosis. Okay, and this is one type of Parkinson disease gate. And these are the gate cycle. Okay, so in the gate cycle, you need to attend this different type of phases, because one gate cycle is composed of two phases. One is called the start phase, another is called the swing phase. So it is a common term. Okay, so I'm not getting into details all the terms. Okay, then after that you need to apply some event. So event means the heel strike. It is in one event. So whenever you first walk now, so your one of the leg is touches the ground. So this is called the heel strike. It is an event. So how automatically? So the software that we have developed, so it will just tell you that how automatically you can detect your event. Okay, so there is a lot of event detection algorithms are available that my students, PhD students are working in this field. Okay, so here in my lab, so the kinet that I was talking about. So in the kinet, you will have the 4 different type of images. One, for the different type of data stream. One is called the color, another is called the depth image, as you can see in the figure number B. Next is called the body indexed image, another is called the skeleton. So from the kinet, you can automatically extract the skeleton. So that is the great advantage of the kinet. And from the skeleton, you can see there are different markers are there. So this is called the joint coordinate. So this is called the joint coordinate position. You could go to X, Y, Z. Okay, so from the joint coordinate positions, you could apply some techniques to compute the joint angle. Okay, or any other parameters that you can think. So this is this experimental setup with the multi-kinet environment. So it is our approach that we have thought of it in this way. Next is in my lab. So this EEG device is there because my student is working in this work field. So capturing this EEG data, and it is a 14 channel EEG, and it has got this is an wireless connectivity, so you can directly connect your data in your computer, and different type of. So my PhD students is capturing the ambulatory motion capturing. So this is very wonderful research that we are going on in my lab. So there's a machine intelligence and biomotion lab. So this lab that I have developed in computer science department. If you just explore it, MIMB .NIT. Okay, MIMB NIT.in. If you just search it, you can get all the details of this thing. So recently, I have got one interesting project in the field of cognitive science that is called from the Indo-Korean project that I recently got it from the Department of Science and Technology, and with the joint collaboration with the KAIST University, Korean Advanced Science and Technology. That is a very wonderful university in South Korea. So we are going to start this work from coming March. Okay, so we are just waiting for this funding. Okay, so this project is approved. So it is basically on the cognitive. Okay, how we can monitor the elder people, because in the COVID time, so they are very frustrated and they feel very panic. Okay, how to take do the daily activities and all other things. So now how the older people that we can using some kind of strategy that we could are going to make some kind of strategy using some machine learning techniques and the cognitive science approach, so that it will be useful for the older people and also other people also in this field. So it is entirely, so you could just go through my webpage, so you could get the details of the things. Okay, if you're interested. So now here these students are walking on treadmill, and as you can see, different kinets are there. This is called the multi-kinet setup, as well as also some IMU sensor has also attached. It is hip and knee. Okay, and person is focusing to see the external, I mean some external stimuli are projected on the screen, and the subject is just seeing this external stimuli, and his thought process is going on. Okay, so I am projecting different external stimuli, and the person is watching those external stimuli, and at that time that person data was capturing. One is called the EG data, another is called is your get data. Then after that, I'm trying to find out this relationship between these cognitive states and this your walking pattern. So these are the things that Sumit, my PhD student, that is working in this area. So now this is my details experiment settled. So I'm not going to get into details of how all these things will take time. So now I just wanted to tell you, those who are interested to work in the field of EEG signals. So these are the band. There's a delta, theta, alpha, beta, and gamma band, and we are analyzing mostly the alpha and beta band, only which because those band corresponds to frontal and the occipital lobe, because you know in our frontal lobe we have the cognitive function, and in the occipital lobe we have the vision. So that is why, so we are just using this thing. So after taking this EG data, so we are doing a lot of processing tasks. Okay, how we are going to get this data. So we are having different slow gate, normal gate, fast gate, and running gate, and we are having the different cognitive states. So now what are those cognitive states? One is emotion oriented states. Okay, so now how we are going to capture the emotion oriented state? The person is watching some projected external stimuli. Suppose I am just showing this Geneva affective picture database. So this picture database are scrolling one by one. Then at that time data is being captured. So that mental state is designated by the emotion oriented state. Next is memory oriented state. So now at that time they remembering any pattern. Okay, such as this is a visual colors, shape, and numbers. Okay, so that is called this memory oriented state. Then a relaxing oriented state. Then picture of sea beach. Okay, puppy playing. Okay, then this database, so on and so forth. So that's the relaxing. Then thinking oriented state, that you are going to solve some logical puzzles. At that time you are walking. Then at that time your data is also being captured simultaneously. So it was my idea that how you could have capture your different emotion oriented states. I mean different cognitive states, and you can segregate, or you can have the different types of cognitive states, so based on these different external stimuli. So now that was the things that we have collected, and we are trying to establish applying some machine learning techniques like this convolution neural network. We are applying this 2D convolution neural network, okay, to do these things. And also we are applying there's a dynamic decision network. So because I don't have much time to uh, discuss all the things, so these are the things that I'm just telling you this idea, okay, how you could think of it, or you can apply the different AI techniques to in your case. Next is called the IMU sensor, inertial measurement unit. So we are using SparkFun. This is SparkFun is a very good company. We are using the very low cost device. So they are providing. So we are using this 9 degrees of freedom SparkFun company. So this prototype that we have built in my lab. So person is just wearing these sensors, and it has got the facility. It does whenever you are going to capture this data. I mean, linear accelerations from accelerometer and angular velocity from the gyroscope, it will automatically store in the micro SD card. So here, as we can see, here there's a SanDisk 16 GB micro SD card is already the inbuilt embedded into this sensor. So after whenever the data collection is over, you just plug off these things, and then you can take out this micro SD card. Then you can dump your entire data to your computer. Then you can start processing. And it is this is very good sensor because its sampling frequency is 120 hertz. Because for the gate analysis, so it is minimum it is 100 hertz. So now these are the tools that we have developed. That is called the Vig Gate Assist. This is a visualization based gate analysis. So entire tool has been made using Python. Okay, and this tool aims to is the process of gate signal processing. Okay, then the gate cycle detections, phase detections, along with the different various spatiotemporal features. So this is here is one separate modules are incorporated for doing pre-processing feature extraction. Okay, and in the pre-processing includes filtering, clipping, calibration, denoising, so on. I mean, this whatever raw data that you are going to get from different sensor, then you need to go through the all the process: filtering, clipping, calibration, denoising. Okay. Then in the second module, we are extracting some spatial temporal features. Okay, and to take these particular decisions. So these are these in the YouTube also. This is there already. So it is like an annotation tool, get annotation tools, which will be useful for the clinical experts if they are going to test it to their patients that to extract events. Okay, so it can do so. We are using the IMU sensor for event detection and the feature extraction. Then 3-axis gyroscope and the 1-axis gyroscope. So all the format is there. So this tool will help you actually it has been made to motivate the researcher in the field of biomedical engineering domain, clinical expert, pathologist, so they can just take up the challenge and they can just do it in this way. Okay, so just a thing. So it is very interesting tool, and we are going to also give it to in the GitHub so that people can download it. So these are the things that you can have. Uh, Processing techniques, calibration, clipping. So the main advantage is that you can immediately, whenever you're going to get some data, so you'll have the provision to see this data. I mean, graphically interfacing is there. Okay, there's an interactive plots will be visible, so that you can manually also you can just annotate it. So if it is not correct, then you can also manually annotate it. Okay, so in this way, it is called this annotation tool. Next, we have done these things, different type of gyroscope event detections or gyroscope data, and also the accelerometer data that we have used it. Then it is the to get this tool. So here is the YouTube link is there, so you can see the YouTube link. So to use this tool, so no need to use any kind of any exe file or kind of things. It is just a web-based applications. Okay, only you need to have these things. So hello everyone. So I'm just not playing it, so it is there already in this. So there's a this board has been extended with this concept of the convolution neural network. So this is the architecture that we have developed, and that is a this work has been published in Biomedical Signal Processing and Control journal. This architecture is a multi-channel deep neural network consisting of the convolution network, one max pooling layer, one dropout layer, one average pooling layer, and each convolution layer uses a rectified linear unit ReLU activation function, and it is compiled with this RMS prop, and as the optimizers. Then you can have the binary cross entropy as the loss function. Then we are using the sigmoid function for the fully connected density layer. So these are the things that we have done, and this tool is designed so basically to help users a graphical interactive platform to annotate the IMU signal easily. And these interactive plots which will enable the user to visualize the different changes that you would like to perform in get signal. So after applying the different pre-processing technique, and then the user can pan and zoom it to analyze the different effects. Very simple web-based applications using a Python. Okay, and this tool can be redesigned for any other types of signal. It is not only restricted for the IMU signal. If you could follow this, you could also use to other type of signals, and the number of algorithms for cycle extraction that we have incorporated. So we are improving with more efficient algorithm. So this is the things that I just wanted to tell you. This is a short introduction of the how AI techniques you can view in different sort of applications, starting from the biomedical, then the medicines, then the clinical aspect, and the pathological applications. So that if you could just look for it, any different techniques that you want to perform, then accordingly. So, Thank you so much for your kind attention. So I think I'm over.
Yes, sir. Thank you so much, sir. It was really a very informative and insightful session. I guess now is the time to move on to the question and answer session. I request all the viewers to drop your questions in the chat box and we'll address them one by one. I hope, yeah. So the first question is from Shaurat Fatima. Sir, for learning AI and to use it in healthcare, we also need to know about machine learning algorithms and programming languages. But as I don't have a background in coding, so will I be able to learn it or work on it? So this is the question.
Okay, Saurav, so yes, so the thing is that as I don't know your background and this coding. So now main thing is that this artificial intelligence uses this it needs this email facilities first of all. Obviously, programming language is required. Okay, so because without programming language, so it will be difficult to code it the machine learning or any deep learning algorithm. So best way if you learn or if you have this, if you don't have any background in coding, so obviously you can pick up. Okay, so first thing that I would suggest you that basic programming language is C programming language. That, as you know, in the undergraduate course that we start with the programming language 1 and 2. So C programming language is C programming. So my first advice to you that you first learn the C programming language. So because everything starts with the C programming language.
Yes, sir.
So basic framework is C.
Yes, sir.
Okay, so you please learn C programming language. Obviously, you can take off the other program like this Python. If you are using this Python, because a lot of facilities in Python, you can have the interactive plots and very, I mean, computationally, it's not too heavy or too this output and to run this very, I mean, large number of data. So I think you could do it. Okay, so okay.
Yes, sir. So, Muhammad Zaid has asked that is there any specific course to learn more on this field?
Yes, so to understand this AI and ML, so firstly, that because there is a good video lectures are available. There is a Andrew NG video lectures. There is a machine learning. So Andrew NG from the Stanford University. So you can also, this is a very quick lecture. So as a short note, that is a 15 minutes for each lecture. So I think you first go on enough to like to work with the field of AI and the ML. So you please go to the Andrew NG lectures. Andrew NG, ANDRUW, NG, Andrew NG machine learning. So I think you should first explore it. Then only you can see
Okay, sir. Now the next question is from Aditi Bhagat. How far is AI in healthcare from being used as one of the primary source of treatment? And is it viewed as a replacement to the healthcare structure currently in place or as a support system to make it different, to make it support system, make it more efficient? So did you get my question?
Yeah. How is AI in healthcare from being used as one of the primary source of this period? Actually, I'm not telling you that this AI is so. These techniques cannot be replace the doctors. First of all, okay. So it can help the doctor to take these certain decisions. I'm not telling you these AI tools that can replace the doctors. No, it is not like that. Because we can also use some suggestion. It will also helping as a guiding tool. Okay, to help the doctor to take a certain decisions. Okay, because we are the engineers. Okay, so we are making some kind of system. How we are going to make these systems? Because you need to have some inputs from your external expertise knowledge. So who are the so I need to acquire knowledge from the doctors because as I already explained, under the expert system is called the mycin. Okay, so the mycin could not be able to be made it if the expert knowledge was not been incorporated. Some experts. This is called a domain expert. So without domain experts, so we cannot do anything. Okay, so we are The engineer just making a model, but the inputs will coming from the experts. Okay, so that's the answer.
Okay, sir. So the next question is from Arjun. He has asked, sir, what is the condition of the particular field in India? Like, is there any startup or any something like this currently going in the country?
So I mean, I don't have any idea about this India, but I could suggest you that yeah, obviously, so nowadays people, as I am working in this field, so a lot of startup company on the data science and AI and the data science startup company are coming up and with some good solutions, and specifically the healthcare domain. Okay, so because exact name I am not remembering. Okay, so you can also search for it. Obviously, there is a huge scope. So people are just moving to this data analytic and the AI. Okay, because you'll have a huge scope. You can do everything can be automated. Okay, so I think you can explore it because you could find there's a lot of startup companies. Yes, it is available.
Yes, sir, definitely. So the next question is from Olivia. He has asked, how can AI be used to find cures of diseases like cancer and other medical mysteries which human doctors are unable to solve?
Oh, that is not possible. Okay, because yes, it is a very interesting question. Okay, because yes, obviously, because expertise knowledge here also come up. Okay, because because at this certain low level of diagram, if you just study, because there is a paradigm shifts. Okay, there's a huge paradigm shifts of these things. Like if you have the good images, I mean, because I am talking about this MRI images kind of things. Suppose if you like to do these things, or cancer is if you like to do some good image processing job in this domain, and if you can extract some features. So sometimes it may show up in this doctor by at his naked eyes could not be able to diagnose this particular disease, although he is much more confident. Okay, although taking his expertise, although he can predict it, yes, this is this disease, whether this person is having this kind of disease or not. Suppose, for instance, this cancer, but still they will love to work for some kind of pathological tool to help to check, to validate their I mean, to validate their opinions or to validate their thinking, whether it is actually correct or not. Okay, but still, so I don't think so. That is obviously because rules has to be followed. Means whatever it is. So if you give the wrong inputs, so you cannot get this correct output. That is the main thing. If you have the good inputs, then you can have this very good outputs. So main thing. If your input is wrong, so you cannot expect that your output will be right. So that is the thing.
Yeah, sir. Now the next question is from Rashi Singh. She has asked that will it be ever able to store human brain memory with the help of AI medically or even after death?
No, I have no idea. Okay, like this, will it be ever be able to store human memory with the help of the AI medically even after death? So yeah, I can. Because I should ignore this question. I'm sorry because what I could tell you that what actually we are doing, because suppose if you know the concept of the artificial neural networks, so what is exactly ANN? So from the concept of the BNN, biological neural net, we are trying to implement this ANN. So it is a very small constituent parts of our BNN. So ANN is a very small. It is a constituent part of your ANN, but it cannot be that this ANN cannot be constituent part of the ANN. Okay. So now we are trying to make a systems with the help of the this ANN. I mean, this is our BNN, but this is a biological neural net. So we are trying to replicate it. So using some of our computational units. So each computational unit is called the neurons. So in the biological neurons, when you are going to map it to your computational aspect, so it is called this computational units. So because as the question says this is a stored human brain memory. So this human brain memory that you are going to store, yes, obviously that is true that you could store your human brain memory means cognitive states. So by using the EEG signal, so means whatever EEG signal or if you using these 32 channels, CG signal or 64 channel, obviously you could get much information that you could store it. Okay, but after that, I mean, even after death, okay, so our memory loss will be there, obviously. So the way that you think after certain year,
Yes, sir. So, we have a few more questions. Next is from Lakshman. He asks, sir, are there any AI techniques now that can predict diseases risk based on our past health records?
many AI techniques are available, so which will help you that to repeat the disease risk. Okay, like that is a kind of so that's why the way that I'm doing the research. So it is called the predictions of the different muscle skeletal disease or recovery predictions of that is called this generative adversarial network, GAN. Okay, and also so here applied this is RNN, okay, recurrent neural network. So those are the things that obviously you could find there is a risk factor or not. Because you need to have the prior data of these things. Okay, person is having the disability, and if the person is having disability after the suppose your friend is a sportsman and he is athletic now. So while doing practice, so he got injured or he or she got injured. Now at that time I'm going to take his data. Then I am preserving it. Then after some rehabilitation, after some doing, so he is going to recover. Then how much recover he is doing, whether any risk factor is there or not. So that kind of predictions are predicted. So there are a lot of predictions that important is on the Mars model, multivariate adaptive regressional spline. MARS. This is a very good tool that you could use for the predicting the risk. So means which will reveal the disease risk. So Mars you can apply it or you can explore it. Multivariate adaptive regressional spline. So it is one of the good predictors. So also I am also my student is also implemented it. So you can also search for it, Mars model, for this predicting the risk. Okay.
Yes. Yeah, so the next question is from Yogesh. Right now, we have sensors receiving signals to coordinate movements. Will there be technology where bionics can be enhanced for touch sensing using AI?
Yeah, I mean, perhaps okay, because that is a yes, it is true that we have receiving signals to coordinate the movement in bionic sensors. Yes, obviously, because it is a obtrusive sensor. If you have the direct connectivity to your body, okay, and if you are taking this data from your body on sensors, okay, then that is connectivity will be improved. Okay, and also there should be a direct connection from a human brain, because in the from the human brain. So whenever you are doing some actions, so now these signals is coming from your sensory organ from your human brain, and it is coming through your spinal. I mean, it is just distributing through your spinal cord. Okay, and it is just distributing this signal through your body. So now based on your hand movement or any other things, now if you find trying to predict that is whether this touch senses I mean these bionics can be enhanced or not for touching. Yes, I mean probably we can do it.
Yes, sir. Yes, sir. The last question is from Frey. Can AI program bionics organ can be as precise as real organs in human?
Actually, this concept is called that is a connection with this. Suppose you are developing prosthetic limb, for instance. Hand. Suppose so, it's a kind of exoskeleton type of system. Suppose if you do not have one hand, or in this case, Then in the prosthetic hand, if you would like to put some kind of like to synchronize to your actual hand, then that may be possible. Okay, so based on this sensory feedback, if you have some sensory feedback from the other, then obviously you can make it. Okay, or you can see that whether how much it is possible.
Yes, sir. So the last question is from Sam. He has asked that as AI tech are computerized, is there a threat to patients' privacy? Because
Yes.
nowadays there is a lot of privacy.
Yes, obviously, that is a good question. That is a yes. All the AI techniques are computerized. It's a very good question, and mostly it's embedded. So whenever it is embedded, you put embedded technology, and you're putting all the AI techniques in the embedded technology, then how the privacy it is obviously. So there is a concern of this. You need to take care of it because this for the vulnerability problems. Vulnerability problems will be there, and we need to think of it, and you need to think this AI technique in such a way so that it must preserve these threats. Otherwise, there will be a problem. Okay, and there is a data dissemination and the transporting data from one organ to the other organs. There will be a problem, and somebody can steal all these things. Okay, so obviously it is this is a threat, and these privacy issues will be there. Okay, and you need to think of it, and you need to go research in these things.
Okay, so I think question and answers are over. Now we are almost at the end of the session. I would like to thank you, sir, for joining us today and for sharing your knowledge and experience with us. Sir, in the future, we will be looking forward to conduct more of such sessions with you. I would also like to thank the viewers for their patient listening, and we hope for your active participation in future events of Genesys. Now, before wrapping up the session, I would like to invite the President of Genesys, Ms. Ria, to give a vote of thanks to Anup sir and our viewers as well. Over to you, Ria.
Thank you, Anubhav. I would like to first extend my thanks to the speaker, Dr. Anup Nandy, sir, without whom we wouldn't have been able to conduct this webinar session. Thank you, sir. And now I would like to thank you to all the viewers who are watching and interacting with us in this meet and also in the YouTube live session. Thanks everyone for joining this session, and hope everyone found it informative. Also hoping that all of you have gained something from this conference during these past 2 days. Now I would like to also thank all the people who are these thanks.